acceptor ions. As a result, potential difference is established across the junction. Soon, it becomes large enough to prevent any further movement of charge carriers. This is called potential barrier or junction barrier or height of the barrier. From the figure, you can clearly see that the potential barrier VO that is set up gives rise to an electric field that prevents the respective majority carriers from crossing the barrier region. Now, let us see what happens when the negative terminal of the battery is connected to P-type region and positive terminal to the N-type region. Observe whether there is any deflection in the ammeter. As no current flows through the circuit, the ammeter reading is 0. This is because the negative electrons in the N-type region get attracted to the positive terminal of the battery, and the positive holes in the P-type silicon get attracted to the negative terminal of the battery. That is, the reverse bias removes the majority carriers, thus increasing the potential barrier. Current flows through the junction if the PN junction is connected to the battery as shown here. Holes and free electrons enter the depletion region due to repulsion at the respective terminals. The reduction of the potential difference and the width of this region causes a large number of majority charge carriers to diffuse across the junction. Holes travel to the right and electrons to the left, constituting a current in the same direction. Thus, the PN junction allows current carriers to flow through it if the junction is forward biased. A device that allows the current to flow only in one direction is called a diode. Thus, PN junction can be described as a diode.
This is very good video which can gives you the highlight how the current can passing from the diodes. What exactly the forward working for the forward biasing and the reverse biasing. There is two terminology which is related to the PN junction diode. The first one is the donor atoms and the second one is the acceptor atom. So the electrons has the characteristic to donate the electrons to the holes, and holes has the capacity to getting the electrons from its vacant place. It means that the N-type material which having the number of free electrons and the P-type materials which having the number of holes. So the N-type materials has the capacity to donate the electrons to the P-type material. That's why the N-type material is known as the donor atoms. So in many time in your examination you are asked what exactly the donor atom, or define what which is known as the donor ions or the donor atoms. So the N-type material has the capacity to donate the electrons. That's why it is known as a donor atom. And the P-type material which has the capacity to collect the electrons from the N-type material. That's why it is known as an acceptor, because they accept the electrons from the N-type material. That's why the P-type is known as an acceptor. So these are the very terminology which is related to the P-type material and the N-type material. Here the PN junction, now give the definition and the uses of the PN junction diode. When we are making the PN junction PN with each other and making one PN junction diode, it can be used in many and the various applications in the electronic circuitry. It can be used as a rectifier, it can be used as a clipper circuit, it can be used as a clamper circuit, it is used as a voltage doubler circuit. So it has a many number of other very vast uses in electronic appliances, PN junction diode. Some of the diode which we can discuss in related to the PA type material and the N type material. The second important diode which is mainly used in electronic appliances is a Zener diode. Zener diode is normally used in a reverse breakdown or in a reverse direction. So it's a very interesting characteristic of the Zener diode is that it can be used in a forward bias like a traditional diode or the PN junction diode, but it's mainly used in a reverse bias direction. So it has the sustainable capacity on the reverse biasing is around 200 voltages. So it's a very large capacity to handle the reverse bias, and that's why in a mainly commercial field the Zener diode is preferred because it has the high amount it's a high reverse bias handling voltage handling capacity. The next one is the Schottky diode. The symbol of the Schottky diode is such like that it makes the symbol S to that. Later onwards, I just defined all the symbols of all the diodes, and this diode are designed such like that the very fast switching time. So the response time of such kind of device diode is very fast. So where we have to use the very in digital circuitry where the switching where we want the switching time is very high, that 1 to 0 and 0 to 1, that's at that time and at that places we have to just use that such kind of diode like a Schottky diode. Then next is a light emitting diode, and which is normally used known as a LED. Friends, whenever we are applying energy to any material, they just reflect the energy in a two form, either in a light or in a heat. So most of the devices are reflect the energy for heat, like a PN junction diode, Zener diode, etc. But the material the light emitting diode are the device which can emit which can reflect the energy in a form of light. That's why that emit the light, that's why they are known as a light emitting diode. Now just give the all the symbols of the diode. First of all, the PN junction diode. PN diode is such like that where this is our anode and this is our cathode. The next, that is a Zener diode. The symbol is such like that. First you have to make the normal diode, then the symbol is looks like a Z. Then after the Schottky diode. Schottky diode. Again you have to just make the symbol of diode, but the symbol is looks like your alphabetical character, that is S. And finally that is LED. Again you have to make first the normal PN junction diode. It emit the light. It means that you have to make such like that emit the light, and this is the photons which can emit from that device. And here I have to just mention again one device, that is photodiode, because many times the students are just very confused between the LED and the photodiode. Again you have to just make the device the diode, PN junction diode, but photodiode get the light, so you have to make the light like that. So light is comes to the device, then it is known as a photodiode, but when the light is go from the device, then it is known as a LED. So this is very minute difference between the LED and the photodiode. Again there are number of diodes in like a tunnel diode. All these diodes are used in various applications. So friend, this is all about the PN junction diode and the types of diodes. Now just move towards the transistor. What exactly the transistor is? As we already talked that the diode has the two terminal, anode and the cathode. So the device who has the three terminal is known as a triode, and the triode is normally known as a transistor, where the current is normally transferred from the low resistance to the high resistance. These are some of the symbols, and these are some of the parts of types of the transistor. It has the mainly three terminals: emitter, base and collector. Later we talk about that all these terminals. The very first BJT. Now BJT is terms as a bipolar junction transistor. Why it is known as a bipolar junction transistor? Because it has a when the current passing into the in this kind of transistor is only due to the electrons and the number of holes. So electrons has the charge, negative charge, and the holes is a positive charge. That's why the two charge or the two types of the charge carriers, positive and the negative, that's why it is known as a bipolar junction transistor. And if any kind of transistor where the current is passing only from the one polarity, either the electron or the hole, who is the majority in a charge carrier, it is known as a unijunction transistor. And this is the first ever transistor which is ever found in this world. Is invented in around the 20th century. Now these are the three scientists or the three engineers which can invent the transistor. Mainly the prizes goes to the Shockley, who is the inventor of the transistor. And this is the figure for the basic transistor which they made at the 20th century, and they got the Nobel Prize for to making such kind of electronic appliances. And when the transistor is made, the overall revolution of the electronic circuitry and the electronic appliances goes raised very fast. So whatever we see, the electronics appliances and the measure electronic devices, that all such kind of just grace is given to these three scientists. And after making the transistor, the Intel company invented the IC, that is known as a integrated circuitry. So that integrated circuitry contains the number of transistors inside one periphery or inside the one silicon chip. So we are comprises the number of transistor, the working of the number of transistor into one single chip, and that single chip is known as the integrated circuitry IC. How actually the transistor is work? Here there is a figure. The emitter and the collector. Emitter is a device who emit the electrons. Collector are the device who collect the electrons. So that's why the name is given to by that. And the base is that part which provide the emitter and the collector to combining. This is the first ever transistor, how it is looks like. This is the first bipolar junction transistor which is made by the Shockley. How actually it works? The base is just a controlling terminal to emit the electrons and passing to the collector side. So the symbol is again looks like that. So whenever we have to define the emitter, the arrow is always given into transistor at the emitter part. And it is shown when the current or where the current is flowing from the device. That is the basic model of the BJT transistor, when two diodes where it is a PN and PN are connected with each other and making one device, that is NPN. It means that where the P type material is sandwiched between the two N type material, that transistor is known as a NPN type transistor. So the BJT is mainly two types, NPN and the PNP. Now what actually the PNP is making? The one N type of material is sandwiched between the two P type of material, then it is known as a PNP type of transistor. And how actually it is identified? If the arrow is go outer side, then it is known as a NPN transistor, and if the arrow is inside, then it is known as a PNP type transistor. It means that if the current is entering into the device, then it is a P type material, and the current is go beyond or towards the from the device, then it is known as a NPN type of transistor. There are the three terminal, that is emitter, base and the collector. These are the main three types of the terminal in transistor, where the high amount of emitter is a very highly doped, collector is very lightly doped, and the base is in between the emitter and the collector. It is not as much highly doped as emitter, and it is not as low lightly doped is the collector. So it is its doping is lies between the emitter and the collector. This is the basic model of the BJT. So the current passing from the emitter terminal is known as a IE, emitter current. It is flowing from the base, that is a base current, and flowing from the collector, that is known as a collector current. And if we are finding the operation of the NPN transistor or the PNP transistor, we can conclude one sentence that the IE is almost equivalent to the IB plus IC. So whatever the emitter current flowing from the device it is the summation of the base current and the collector current.
Now let us see the construction. A PNP transistor is like two PN junction diodes which are placed back to back. At each junction, there is a depletion region which gives rise to a potential barrier. The external biasing of the junction is provided by the batteries VEE and VCC as shown in the diagram. The emitter base junction is forward biased and the collector base junction is reverse biased. Since the emitter base junction is forward biased, a large number of holes cross the junction and enters the base. At the same time, very few electrons flow from the base to the emitter. These electrons, when they reach emitter, recombine with an equal number of holes in the emitter. The loss of total number of holes in the emitter is made by the flow of an equal number of electrons from the emitter to the positive terminal of the battery. The flow of holes from the emitter to the base gives rise to emitter current IE. In the emitter, IE is due to the flow of holes. But in the external circuit, the current is due to the flow of electrons from the emitter to the positive terminal of the battery, VEE. The holes diffuse through the base. These holes take a very small time to flow through this region before they reach the depletion region. During this time, a very small number of holes recombine with an equal number of electrons in the base. Because the base is lightly doped and very thin, this number is very small. The loss of total number of electrons per second is made up by the flow of an equal number of electrons from the negative terminal of